Assalamualaikum warahmatullahi wabarakatuh and a very good morning everyone. We invite all guests to prepare as the competition will begin shortly. Please ensure your devices are on mute to avoid any disruptions. Thank you. I am Azrin Shafika Nabila binti Azlan, your MC for today. Ladies and gentlemen, we are gathered today for the UTHM Materials Lecture Competition MLC 2024. Your presence and participation are highly appreciated and anticipated. We will begin our competition with a prayer led by Izzat Amirul Arash bin Muhammad Nizam.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين يا كريم يا ودود. Indeed, we have gathered here today to express our appreciation for your amazing gift. Make us your servant who are always thankful, whether it is small favor or large favor. Ya Rahman, Ya Rahim, we hope your blessing for the Material Lecture Competition MLC 2024 concluding program. You must be aware that we wish to benefit from your rahmah. Inspire us to adore everything that is good and make us, our lecturers and our leaders to continue istiqamah, high devotion and strengthen the community, society, nation and country. Adorn us with the noble character, patience, obedience and conformity to rules and regulation, and do not leave us forgetful and careless in carrying out our obligations. Ya Zal Jalali wal Ikram, please grant us excellent health, mental fitness, mental calm, and spiritual strength. With it, we want to be able to meet problems, compete, and enhance the dignity of ourselves, our family, the community, and the country. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وصلى الله على سيدنا محمد وعلى آله وصحبه وسلم والحمد لله رب العالمين.
Thank you, Izzat Amirul, for the prayer just now. On behalf of the organizing committee, we extend a warm welcome to all of you to UTHM Materials Lecture Competition, MLC 2024. For your information, UTHM MLC 2024 was organized by UTHM IMM Student Chapter. So, to provide more information about UTHM IMM and MLC, we would like to invite Associate Professor Technologist Dr. Hamimah binti Abdul Rahman, Advisor of UTHM IMM Student Chapter, to deliver an opening speech.
Thank you, Ms. Azrin. Assalamualaikum and a very good morning. I extend a warm welcome to all those gathered here today, physically or virtually, especially to our honourable judges and distinguished participants. So welcome to UTHM IMM Materials Lecture Competition 2024. Okay, first of all, I would like to express our gratitude to our judges, Associate Professor Technologist Dr. Rizwal Haq Abdul Haq, Associate Professor Technologist Dr. Liti Chuan, Technologist Dr. Muhammad Azham Azmi and Dr. Nur Azam Badrul Zaman as the head judges for today's competition. Okay, I would like to share a brief introduction on the backgrounds of Materials Lecture Competition. Okay, for your information, the MLC is a brainchild of the Institute of Materials Malaysia, IMM, to give a platform for the young students and researchers to share their work progress in related materials, not restricted to the private and public universities as well as industry in Malaysia. So they are allowed to showcase their ability to communicate their research work or projects related to materials to a diversified audience. Okay, so the first national MLC 2020 national level was organized by IMM on 2012. Okay. So of course, the competition does not stop at the national level. So after the national level, MLC, so the competition continues to the Young Person World Lecture Competition, or we call it as YPWLC. Okay, so at YPWLC, the winners from the finals, okay, from uh, countries and regions where Institute of Materials, Minerals and Mining, IOM3, has their international branches or sisters institution. So all those winners will compete on the final stage, world stage, which will help around the world, okay, at various locations. So the first YPWLC was organized in London, okay, in 25, and since then has traveled to different locations on 4 continents. Okay. So, however, since pandemic 2020, so the Young Persons World Lecture Competition is being held online. Okay. So for your information, our university, UTHM, okay, has started taking part in national level MLC in 2018. So therefore, this will be our 7th year of participation, inshallah, where the winner of UTHM MLC 2024 will be our representative at the national level, which will be held in October this year. Okay, so before concluding my remarks, I would like to express my appreciation to the UTHM IM Student Chapter Committee for their hard work in organising this competition. So your commitment towards this program for today and for the last 5 years is very much appreciated. Okay, to all participants, all the best and good luck. So I raise my speech here. Thank you.
Okay. Thank you, Dr. Hamimah, for such a wonderful speech. Now, I would like to introduce our esteemed panel of judges for today's competition. Dr. Noor Azam Badaruzaman as the head of judges, Associate Professor Technologist Dr. Rizul Haq, Technologist Dr. Muhammad Azham Azmi, Associate Professor Technologist Dr. Lee T. Chuan. Please note that all panels' decisions are final and individual scores are confidential and will not be discussed. Before we begin, let me quickly explain the rules for MLC 2024. I'd like to remind all contestants to be ready at least 5 minutes before your presentation. Each presentation will last for 50 minutes, followed by a 10-minute Q&A session. Contestant will be evaluated based on structure of the presentation and clarity of explanation and argument, standard of presentation, personal enthusiasm for the subject, ability to deliver presentation compellingly, technical content of the presentation, clarity and relevance of any visual aids used, ability to deliver a concise and meaningful summary at the end of presentation, ability to present within the specified time allocated, ability to handle judges' questions. Dear audience, please ensure that no guidance or prompts are given to the participants, as this may disrupt the competition. Thank you for your cooperation. Without further ado, I would like to welcome our very first contestant for today, Lu Yun Hearn, with the title Investigation of the Deposition of Conductive Ink on Multiple Substrates with Different Substrate Surface Energy and Ink Surface Tension Properties.
Hello and welcome to my presentations. My name is Luyan Hertz and I'm excited to share with you my research on the investigations of depositions of conductive ink on multiple substrates with different substrate surface energy and ink surface tension properties. I have had the pleasures of conducting this research under the guidance of my supervisor, PM Dr. Radin Karhidra bin Kirotin. First and foremost, it is very important for us to understand about what is conductive ink, the type of conductive ink, and the tool used for printing and depositing conductive ink. Conductive ink is a specialized type of ink that is formulated to conduct electricity. It contains conductive materials such as metallic particles, carbon-based materials, and conductive polymer. When this ink is applied to a substrate and cured, it will form a conductive path that can be used in various applications like printed electronic, flexible circuits, and RFID tags. There are several types of conductive inks, including metallic inks, carbon-based ink, and conductive polymer inks. Each type has unique properties and applications. Conductive ink is chosen based on factors such as conductivity requirements, cost, flexibility, and the specific applications need of the electronic device being produced. The two used for printing and depositing conductive inks are equally important. Common techniques include screen printing, inkjet printing, shrink depositions, and flexography printing. Before delving into my research, I would like to introduce the motivation behind it. The primary motivation arises from the limitations of existing models. The previous mathematical models developed by Wozi in 2002 only consider ink depositions on generic substrates and printing on the fly. He does not account for variations in line width that occur when different substrates are used. Given the expanding range of substrates and diverse applications in printed electronics, a more comprehensive and adaptable mathematical model is necessary. Applications such as antenna, smart textiles, sensor, solar cells, and supercapacitors all require precise and varied substrate interactions. Developing a robust models that account for these variations is essential for optimizing performance across different applications and substrates. When printing on various substrates, two crucial variables are substrate surface energy and ink surface tensions. These factors significantly impact the quality, uniformity, and adhesions of printed patterns. As shown in the picture, different substrate surface energy value leads to varying contact angle, which in turn affects the line width of printed conductive ink. And why the line width is mentioned? This is because the line width is crucial for applications such as antenna, RFID tags, and sensor. These devices require precise frequency for transmissions, and the line width directly affect the resonance frequency, which can be shown on the formula. Accurate dimensions of the conductive tracks are essential for proper functionality. Therefore, improving line width predictions accuracy across various substrates is vital for the performance of these applications. Next, I will introduce a bit about my research. The printing technique used in this study is shrink deposition technology, and we will print conductive ink on substrates with varying substrate surface energy properties. Additionally, substrate surface energy and ink surface tensions will be integrated into the existing models. These step in to refine the mathematical models and enhance its predictive capability, thereby improving the accuracy of line width predictions. The significance of this study lie in its potential to enhance precision in printed electronics. These advancements benefit both the industry and research institutions by improving the manufacturing process and reducing experimental costs associated with decreasing the trial and error process. The first step in the methodology will be measuring substrate surface energy. 9 selected substrates will undergo this process. A droplet of distilled water will be deposited on each substrate, and the contact angle will be measured. Using Young's equations, the surface energy value will be calculated. The next step involves preparing the conductive ink. For this research, the silver ink used is AG806. These silver inks will be mixed with toluenes to achieve a viscosity of 2.4 PAS. Once the desired viscosity is reached, the ink surface tensions will be measured using the do-no-ring method. Once the silver ink preparation is complete, the string deposition process will be carried out. The inks will be deposited according to the parameters determined by simulations. After the lines are deposited and fully cured, the line width of the conductive inks will undergo morphological analysis using an optical microscope. The percentage error will then be calculated to assess the accuracy of the depositions. For the simulations and experiments, there are three main steps: preliminary, first, and second. The preliminary step involves testing with the existing mathematical model. The first step incorporates the substrate surface energy variables, while the second step includes both substrate surface energy and ink surface tension variables. Starting with the preliminary step, the result indicates that the line width exceeds 2 mm with a percentage error greater than 150%, whereas the target line width is 0.8 mm. This demonstrates that the current mathematical models is inadequate for these conditions and require modifications. Here are the tables showing the experimental results for low, medium, and high substrate surface energy conditions. This table presents the printing speeds and the corresponding percentage error for each SSE level. Next, I would like to discuss the comparisons between the preliminary simulations and the first simulations. The graph clearly shows that integrating the substrate surface energy variables into the existing models result in an increased printing speed. The highest printing speed for preliminary simulations is only 0.52 mm per second, whereas the highest speeds for the first simulation reach 33.93 mm per second. For the comparison between the preliminary experiment and the first experiment, the graph indicates that the percentage error decreased after integrating the substrate surface energy into the existing models. In the first experiment, the highest percentage error is 32.50%, while the lowest is 3.75%. These reductions in percentage error is attributed to the decrease in line width, which results from the increased printing speed. With a faster printing speed, the deposition time at each pot is reduced, leading to less silver ink being deposited in any given area. Here are the tables showing the experimental result for low, medium, and high substrate surface energy conditions for second simulations and experiments with integrating substrate surface energy and ink surface tensions into existing models. The table presents the printing speeds and the corresponding percentage error for each substrate surface energy level. Next, I would like to discuss the comparison between the first simulations and the second simulations. The graph clearly shows that integrating both the substrate surface energy and ink surface tension variables into the existing models result in a decrease in printing speed. In the second simulations, printing speed ranged between 0.17 and 0.97 mm per second. This decrease in printing speed after incorporating the surface tension variables bring the result closer to those observed in the preliminary simulations. For the comparisons between the first experiment and the second experiments, the graph shows that the percentage error increased after integrating both substrate surface energy and ink surface tensions into the existing models. In the second experiment, the highest percentage error is 733 and 75%, where the lowest is 381 and 25%. This significantly increased in percentage error, which is even worse than the existing models without additional variables. This is attributed to the increase in line width resulting from the decreased printing speeds. In the context of my research, three sustainable development goals are particularly relevant. First, SDG 9, industry, innovations, and infrastructure. This research promotes innovations in the field of printed electronics and support the development of sustainable industry practice. Second, SDG 12, responsible consumptions and productions. By optimizing the deposition process, the research aims to reduce material waste and enhance resources efficiency, contribute to more responsible consumptions and productions. Third, SDG 13, climax actions. Reducing material waste indirectly helps lower greenhouse gas emissions, thus contributing to climate change mitigations. These goals are central to advance both technology innovations and environmental sustainability. In conclusion, integrating substrate surface energy into Vozy equations enhance the precision of intracts with estimations in printing. The inclusion of SSE allows for more accurate adjustments of printing parameters, which improve process control and uniformity. However, adding in surface tensions alongside substrate surface energy complicates the models and can reduce the accuracy of in-line with predictions. Therefore, a revision of mathematical models is necessary to effectively incorporate both substrate surface energy and in-surface tensions variables. Exploring alternative methods for integrating these variables into the Vozy models may be required to maintain both accuracy and effectiveness. Here are the publications and reward received during my research. Lastly, by advancing our understanding of conductive ink depositions and improving predictive mathematical models, we are contributing to more precise and sustainable manufacturing practice in printed electronic industry. Thank you.
Hello, come out. Okay, okay. Hello. Very good morning to our first candidate, Lu Yun Hun. Is it? Did I mention your name
Yes, morning,
correctly?
doctor.
So I
Yes,
only
correct.
have one question. Okay. So regarding about your research. Okay. So is there any element of curing process conducted during your experiment? And may I know what type of curing process that you
Yes, the
use?
curing process used is inline curing, and the curing I use is halogen lamp.
Halogen lamp.
Yes.
So does actually the curing process also affect the result of your experiment?
For the curing process, because previous researchers has already done, so I just use the optimum temperature in the literature review.
All right, thank you.
A simple question. Why you choose silver nanoparticle and how it contribute to the sustainable goal?
Because for silver is mostly being used, and the conductivity is also higher. And why is contribute to sustainable? Because when I done this research, many of the industry they just use trial and error so that they can get the line width they require. But after I have modified these mathematical models, I will be able to create a formula with what variables, what parameters be needed, so that they can create accurate line width.
Actually, my question is how the silver particles inks contribute to the sustainable goal. It's not the mathematical model.
Silver ink contact the sustainable goal. I'm not so understand about the question.
Okay, you are using several nanoparticle, right? Then
Yes,
how
doctor.
this material can contribute to the sustainable goal?
Sustainable goal. Or how this material can, because the purpose I use this silver particle. Mm, how can I say that? Sustainable goal. Not because I using silver inks so that can contribute to sustainable goal, but I using silver inks and I create these mathematical models, it can contribute to sustainable goal by reducing the waste.
Hello. So my simple question, I would like to know about the printing surface. Does printing surface need to be considered in your manufacturing of this ink?
The printing surface I use is from substrate surface energy. Substrate surface energy can representing the printing surface of the substrate. Because there are various of substrate and being used, 9 substrate and being used, and I calculate all the substrate surface energy.
Okay, thank you.
Okay. My question will be also on the printing surface. So basically, we need to have some sort of cleanliness of the printing surface.
Yes.
So in this case, how clean is clean?
Because when we get the material substrate, we will undergo ultrasonic bath so that we can make sure that every contaminations will be cleansed. And before we send to determine the substrate surface energy, we also clean it before we go to do the experiments.
Okay. Thank you very much.
Okay, thank you.
Okay, thank you Lu Yuhen for such an inspiring presentation. Next, our second contestant for today, Dini Hadirah binti Zulkarnain with the title Influence on GDC SDCC Electrolyte Ratio on the Properties of Dual Composite Cathodes SSC GDC SDCC for Solid Oxide Fuel Cells.
Assalamualaikum and hi, my name is Dini Hajira binti Zulkarnain. So I would like to start my presentation with my title of project, which is it is about the influence of GDC SDCC electrolyte ratio on the properties of dual composite cathodes, SSC/GDC SDCC for solid oxide fuel cells, also known as the SOFCs. So what is actually GDC? What is actually SDCC? What is actually SSC? So I would like to start with the SSC first. Its full name is samarium strontium cobalt. GDC stands for gadolinium dope ceria. And SDCC stands for samarium dope ceria carbonate. So all of them is a type of materials that will be mixed together to give the dual composite cathodes as a result that represents SSC/GDC SDCC for solid oxide fuel cells. A little bit about the background of study. So first, SSC, GDC, SDCC. In terms of this material, it focuses on the electrochemical performance of SSC and GDC, SDCC electrolyte. Why is named SSC and GDC, SDCC is because SSC is a one material and GDC, SDCC will be mixed as a one material, and together they will get the dual composite cathode as a result. So composite performance is about the showcase of the remarkable activity and stability of SSC, GDC, SDCC electrolyte and enhancing the cathode material performance. So a little bit about the material optimizations. It emphasized the need to further research to fine-tune this cathode material, which is SSC, GDC, SDCC for commercial viability. And lastly, about the advancing the SOFCs, it highlights the significance of this research in advancing SOFC technology for enhanced performance and efficiency in energy conversion. So a little bit about the SOFCs. It is a promising technology for clean and efficient energy conversion, which I will explain later on. Why it is highlighted as a energy conversion efficiency is because there will be energy conversion in throughout this project, and I will explain about it later on. So here's a bit about the problem statement of my project. So first, it is about the exploring mixed variations, GDC, FDCC electrolyte powder mixed with ratio of 50-50, 60-40, and 70-30. And why is this ratios? It's because these different range of ratios will give me different range of results, and because of that it will give me results that will give me conclusions and results and discussions that will be going throughout my project. So next is about examining the impact of the GDC SDCC electrolyte ratios and how variations in the GDC to SDCC electrolyte ratio affect the properties of these dual composite cathodes. And lastly, it is to improve the composite quality, and it aims to enhance the electrochemical performance, as I have already highlighted before. So here's is the objectives that I would like to point out. There's two, which is the first one that I would like to highlight here is to fabricate the SSC, GDC, SDCC dual composite cathode powders via ball milling process. This ball milling process is same as another term that is easier for us to say, which is like a mixing process. And this ball milling process, it have certain temperature and speed that needs to be determined, and that is accurate for SSC, GDC, STCC process that needs to be followed so that it can be fabricated. Next is to determine the correlations of GDC, STCC electrolyte ratio on the characteristic of the dual composite cathode. Scope of study about this project. The first one is the composite powder development, which is it will create the electrolyte powders through wet ball milling process that I have already highlighted before, with varying SSC, GDC, STCC with ratios 50-50, 60-40, and 70-30. So these three ratios will give me three different results, because it will go through the wet ball milling process depending on the ratios. So it will be a repetitive of process according to my ratios. And then here we have the electrolyte pellet fabrication using the uni-axial pressing method to fabricate SSC, GDC, STCC electrolyte pellets for each ratio. And next is about the characterizations. It is the assessing porosity and morphology using Archimedes principle and scanning electron microscope SEM respectively for the obtained electrolyte component. So next is the chemical compatibility. It identifies the chemical compatibility SSC, GDC, STCC through XRD phase identification. XRD phase identification, you might wonder what is actually XRD that stands for. So XRD stands for X-ray diffractometers, and it is a machine that will give results as an overall. And then there is a calcination temperature, determining suitable calcination temperature of 680 degrees Celsius. So here I'll be using 680 degrees Celsius for the calcination temperature. And the expected outcomes that I will get through this project is, the first one is about the proper calcination temperature to produce SSC, GDC, SDCC. Second is the appropriate ratio of the SSC, GDC, SDCC electrolyte composite established. And lastly, it is about the dual composite cathode, SSC, GDC, SDCC, that are expected to be compatible with the electrolyte GDC. And this is where it is important, because we really need to know whether it is compatible or not between these materials, as it is our aims for these projects. So here's an additional information on the literature review, and here's a diagram, and it shows about the solid oxide flow schematic diagram with 3 layers of anode, electrolyte, and cathode. So it is highlighted here that 3 layers. As you can see there from the diagram, there's 3 layers, and these 3 layers just shows that it is related to the conversion of energy that I already highlighted from earlier. And its conversion of energy involve the chemical energy to electrical energy, and so this is how it is how this conversion of energy happens in the fuel cells. So here's a bit about the methodology or the flow of how this work will how this project will be carried out. So the first is the starting of the preparation of SDCC powder, and next is the preparation of GDC SDCC composite ratios powder by high energy ball milling, and it is a process that I already highlighted before that needs to follow certain speed and duration and also calcination temperature. So here we will be using specifically speed of a 550 rpm, and it is for 2 hours, the duration at least for 2 hours, and then there will be calcination temperature of 680 degrees Celsius to be specific. And then next we have the composite powder characterizations, chemical compatibility, that uses the phase analysis of XRD, like I said before, X-ray diffractometers, and also chemical bonding, FDR. So next is the preparation of SSC, GDC, SDCC dual composite powder by high energy ball milling, and it is a repetitive process that using the same one, which is about the ball milling process. And the speed still the same, duration also, and also the calcination temperature is the same. It maintained for 550 rpm for 2 hours, and calcination temperature for 680 degrees Celsius. And the same repetitive process which is involved the composite powder characterizations, chemical compatibility, which is XRD, and also FDR, chemical bonding and phase analysis. And here we have preparation of SSC, GDC, STCC pellets. So these pellets will go through the pressure of 1 ton, holding time 1 minute, and sintered at 600 degrees Celsius. So next is dual composite pellet characterizations. We'll go through cross-section morphology, SEM, also known as SEM, and porosity and density, which is the Archimedes principle. And here there will be a little bit about the calculations that will give me numbers of how the porosity and density using the Archimedes principle. Next, after getting the results, I'll go through the electrochemical impedance spectroscopy, EIS, and also measurement for area specific resistance, ASR. So these two process is about EIS is a tool in the process of breaking down total electrolyte impedance into various components of cell. And ASR represent about the ohmic resistance calculated for values of symmetrical cell, and here there will be a bit of calculations to get the value. And it is different because there will be temperature in dry and wet air 500 degrees Celsius, in the range of 500 degrees Celsius to 800 degrees Celsius. And if it's a yes, then like I said before, it will go through EIS, ASR. If it's a no, then I'll have to repeat back the same step from the early stage. So that's it. So here's the graph of the calcination temperature profile for GDC SDCC composite powder. The first one shows it's exactly the same, but I will explain to you how this actually works for the graph. And here we can see that the duration for calcination is 2 hours. Like I said before, it is 2 hours. So the graph shows from 27 for y-axis it will have temperature, and the x-axis is about the time/minute. And it starts from 27 degrees Celsius, and the maximum it can go for 680 degrees Celsius. So from 27 degrees Celsius, it will go outwards for some amount of time. And then for the second one that is plotted here, it shows that it will be constant for 120 minutes at the 680 degrees Celsius, and then it will go downwards until it meets the 27 degrees Celsius temperature back. So here's a bit about my preliminary work that I have already gone through for this project so far. And these figures shows the raw results of the GDC SDCC calcined ratios. So there'll be three different ratios here, which is 50-50, 60-40, and 70-30. So the first one is 50-50 calcine. As you can see, here is the graph. that I have already gained from XRD, which is the X-ray diffractometer, and it shows somehow it shows quite same result because it is a raw material. After it is analyzed, there will be results that will be more specific and more significant for these ratios to show how different it could be. So here is the raw GTC STCC 50/50 calcine figures 1.2, and figure 1.3 shows the raw GTC STCC for 60/40 calcine. And lastly, for the figure, lastly, it shows the raw GDC STCC figure 70/40 calcine. And that's it from me. So as an overall, I would say that SOFC solid oxide fuel cells is a promising technology for clean and efficient energy conversions, and these materials will aims about how these materials, these SSC, GDC, SDCC will give a stronger for particles, and particle size will become stronger, and that is the aims for these projects. As you can know, the SDC itself is already there for the marketing, but SDCC is a SDC plus carbonate that needs to be done by ourselves, and then only it can be mixed, and next we'll be going through the process of mixing and all. So this process will shows how it will emphasize particles to be stronger and better in advancing the SOFC's technology itself. So thank you so much. That's all from me.
Okay, thank you very much, Miss Dini Nadira. So I just start the question. Okay, so what's the most challenging part of your research, and how do you overcome it?
I think challenging part where I'm much more because the SEC is not have knowledge that I'm market. So I guess more about it through the laboratory because
I think yeah, she's inside the car.
so the three
Somehow we cannot hear you. I think the line was breaking. I think you are driving or somewhere. I think you are wearing a seatbelt. So yeah, so maybe I'll proceed with the next question.
Okay, Dini, what is the basis of the calcination temperature selection?
pardon.
The basis of the selection for calcination temperatures.
Sorry, I cannot.
Okay, I'm asking about the calcination temperatures. Okay, so what is the basis of the temperature selection?
Yes.
So I think the question kan maybe the line tak bagus. Tak boleh.
600 to 1000 degrees Celsius.
I think maybe we can proceed with the third.
Okay, thank you to Dini Hadira for your detailed presentation. There seem to be some technical issue. Okay, so it's fine. We will continue with presentation from Natasha Salsabila with her presentation entitled Effect of Amine and Thiol as Functional Groups on Gold Nano B Pyramids, Properties for Glucose Sensing.
Are you familiar with this? Or even this? I'm sure that all of us like to consume them because they are very delicious and convenient. You can get them anytime and anywhere. And if you observe, you will see that people in nowadays even prefer to consume sweet drinks rather than mineral water and, of course, lack of exercise. So, this simple thing can give us a brief understanding of why diabetes is very popular and still become an issue for the next few years. Diabetes is so scary. It can cause so many deaths with only 60% had a proper diagnosis. This condition will worsen until at least 2045. So the need for glucose sensing has gained much attention and improvement over the years. The existing methods are glucose meter and urine testing. Can you imagine how many diabetic patients must feel pain when checking their blood glucose level through glucose meter because it's invasive? Or if you prefer to do urine testing on the hospital, you should wait for a long time to get a result. So this is where plasmonic sensor come from. The sensor can be performed in non-invasive way, fast detection, and can be performed without an expert needed. However, the challenge is to do glucose sensing using plasmonic sensor need to be improved in the selectivity and stability aspect. But wait, how can we develop a sensor with those of advantage and also with improved selectivity and stability aspect as well? Okay, one of ways to achieve that is through sensing material modification. So here I am, I'm Natasha, and today's lectures will discuss about the modifications of gold nanobiopramids using amine and thiol groups as sensing material for glucose sensing application. Basically, there are a lot of materials on this earth, both in bulk size or nanoscale. So nanoscale material, well known as nanoparticle. For your information, nanoparticle itself has increased surface area that is very suitable for sensing application. But why did we focus on metal? So besides high surface area, metal nanoparticle is very reactive to living cell and it's very promising feature to be applied in biosensing application and can detect low concentrations of analytes. There are a lot of types of metal nanoparticle with gold become the popular one because it's very easy to modify or to fabricate with other molecules and linkers, so it can be used to detect various things. And then we came up to the next question. What type of gold nanoparticle they can be used? Well, gold nanoparticle with bipyramid shape is chosen because it has higher sensitivity than other form and the facile functionalization process with other linkers or other functional groups, so it can be used to detect certain molecules. In this case, we want to use gold nanobipyramids or GNBPS for glucose sensing applications. So the functional group used are amine and thiol because they can construct a strong chemical bond with glucose on gold nanobipyramids or GNBPS surface. Then, how can we produce gold nanobipyramids or GNBPS? Okay, the most popular method to fabricate gold nanobipyramids is through seed-mediated growth methods or SMGM, which divided into seeding and growth process. In seeding, we produce gold nanoparticle as a seed, then the seed will grow into bipyramid shape through the growth process. After that, we functionalize gold nanobipyramids or GNBPS for 0.5 until 72 hours using amine and thiol groups to modify the surface of GNBPS so it can properly bond with glucose molecule. The interaction between amine and glucose molecule is known as imine bond, while thiol and glucose molecule is known as disulfide bond. Okay, we already know how to synthesize and functionalize golden biopermits or GNBPS, and here is the result solution. For synthesis, there is a mechanism of growth from seed. So an increasing time leads to decrease in gold source, which affected to the productions of truncated and GNBPS cannot grow in perfect shape. Figure 2 shows a GNBPS or amine functionalized GNBPS for 0.5 until 72 hours. It can be seen here that after 12 hours, the solution turned light yellow. Figure 3 shows the GNBPS or tile functionalized GNBPS for 0.5 until 72 hours. So it can be seen here that after 12 hours, the solution turned darker. Okay, this is the characterization result of pure GNBPS using UVVs, XRD, PSAM, and then TM, zeta potential, and the last one is FTIR to confirm that golden biopyramids or GNBPS has been successfully synthesized. Next, we move on to the AGNBPS. This is the UPV's results of a GNBPS or amine functionalized GNBPS. If you see here, in general, the spectrum shifted into the red region, indicates increasing in the aspect ratio. For your information, aspect ratio itself is the ratio between length and width of GNBPS. Based on this result, the highest absorbance value is obtained at 3 hours with over 12 hours, there is no peak anymore in the spectrum, indicates that there is no nanoparticle remaining as a side effect of over facilitation time. Yeah, this is the XRD results for a GNBPS. So based on this result, the highest additional peak is obtained at 3 hours, which consists of amine molecules such as Si, N, O, and H. Indicates that the highest binding reaction between amine groups and GNBPS surface is obtained at 3 hours. Next, PSAM. So from this result, it is obtained that the highest surface density is in 3 hours with value of over 59%. From TM, we obtain that the tip and slope angle of a GNBPS is 1.01 times higher than pure GNBPS, indicating an initiation of surface scraping phenomenon which affected by the usage of amine groups. With zeta potential measured at 2.5 millivolts, which increased from pure GNBPS. And the last one, from FTIR, we obtained the utilization of amine groups to modify the surface of GNBPS can influence for the wave number shift. Next, we move on to the TGNBPS, and this is the UVV's results of TGNBPS or tile functionalized GNBPS. If you see here, in general, the spectrum shifted into the blue region, indicates a decrease in the aspect ratio, so a bit differ from a GNBPS before, and the highest absorbance value is also obtained at 3 hours. With over 12 hours, the spectrum turned broader, indicates that the shape of nanoparticle is not bipyramid. Okay, this is the XRD pattern of TGNBPS, and based on this result, there is no additional peak as a GNBPS before, but if we see here, the usage of tile can influence for the increasing in 111 and 200 plants. Next, PSAM. So from PSAM, the highest surface density is obtained at 3 hours as well, with value of over 75%. From TM, we didn't see any morphological change as a GNBPS before, with zeta potential value measured at minus 0.5 millivolts, which decreased from pure GNBPS. And the last one, from FTIR, we obtained the usage of tile groups to functionalize the surface of GNBPS can also affect for the wave number shift.
Yeah, we already know how to synthesize and functionalize gold nanobipyramids or GMBPs, and we also know about the properties change after the functionalization process, and here is the proposed mechanism of functionalization itself. So amine groups can influence for the morphological change, while thiol allows for the nanoparticle agglomeration. So this corresponds with the general understanding of zeta potential value, where positive charge of amine influence for the agglomeration inhibition, and vice versa for negative charge of thiol. Yeah, we already know how to modify the gold nanobipyramids or GMBPs, and then we came up to the next stage. How can we develop a plasmonic sensor for glucose sensing application? So here is the setup, which consists of light source, fiber optic, chamber, spectrometer, and the last one is computer equipped with a software analyzer. So gold nanobipyramids as sensing material and glucose as targeted analyte will be placed in the transparent cuvette and put in the chamber. Light from the light source will be exposed to the chamber through the fiber optic. When gold nanobipyramids detect glucose, it can cause a spectrum shift towards the localized surface plasma resonance or LSPR spectrum. Then, the spectrum will be recorded by the spectrometer and visualized using computer software. For your information, localized surface plasma resonance or LSPR is the optical phenomenon conducted by metal nanoparticle when they are radiated with light in a specific wavelength, and it's very sensitive to the surrounding medium change. Okay, now, moment of the truth. So we test pure GNBPS, and then A GMBPS, and the last one is T GMBPS for plasmonic response mechanism. So based on this result, it is confirmed that pure GMBPS, A GMBPS, and T GMBPS can detect different medium through wavelength shift and also intensity change. Okay, now of course, we want to know about what is the optimum functionalization time so we can get the best signal response for plasmonic sensor application. So based on this result, 3 hours of A GMBPS and T GMBPS produce the highest signal response compared to others, denoted by the highest intensity change value. And this is the selectivity test of pure GNBPS, A GNBPS, and T GNBPS. If you see here, A GNBPS and T GNBPS perform a higher selectivity response than pure GNBPS, with A GNBPS is the greatest one. Then we test the stability for pure GMBPS, A GMBPS, and T GMBPS. We can see here that A GMBPS and T GMBPS produce the higher stability response than pure GMBPS through a lower error value, with T GMBPS produce the greatest stability response than other. Okay, now I will summarize the whole discussion. So overall, gold nanobipyramids have been successfully synthesized using SNGM and functionalized using amine and thiol groups, with amine can influence for the morphological change and thiol influence for the nanoparticle agglomeration. Based on characterization results and plasmonic response testing, it is obtained that 3 hours is the optimum time to modify or to functionalize the surface of gold nanobipyramids using amine and thiol groups. And when we test into the plasmonic sensor for glucose sensing application, it is confirmed that it can improve the selectivity and stability aspect. So that's all from me. Thank you for your attention and see you next time.
Okay, good morning, Natasha. Thank you so much for your presentation. May I know what are the limitation or disadvantages of your method compared to current method?
Okay, thank you for your question. So if we talk about the limitation using plasmonic sensor is about to develop the portable one because in the laboratory scale, we already seen in the presentation, it contains a lot of part, a lot of integration to make the portable. So the limitation is, and actually it is our task to further project. So we consider about the portable one. So we should think about how can we integrate this all of part, this all of things into the small size, so we can make them in the field testing in the real sample. I think that's all from me.
And second question, how about the cost effectiveness compared to the current method?
Okay, about the cost effectiveness, the gold nanopyramids use gold as precursor, as a gold source, right? If we see, if we purchase gold itself, the cost is 4,000 ringgit, but 4,000 ringgit consists of 10 milli of gold. When we develop plasmonic sensor, we just use 0.05 millivolts. So it's very cheap if we compare. So based on 10 milli, we can develop many of plasmonic sensors. So there is no issue from cost aspects.
Okay, I have one question. There are a few types of glucose. Okay, how will your technique able to detect each and every type of glucose?
Okay, thank you for your question. So I think you mean by type of glucose is like monosaccharide, disaccharide, and something like that. So in this stage, basically we just focus to develop in the laboratory scale. So we just use the commercialized glucose, and the optimum molecules on that commercialized glucose is monosaccharide. But I know in the real sample, there is very complicated, right? There is very complex solution. So this is become our consider as well to proceed this into the future one, into the future portable. So if we want to proceed this laboratory based scale into the portable one, we should consider about the replacement of another functional groups because in fact, amine and thiol, they not strong enough if we compare to glucose oxidase. But if we use glucose oxidase molecule, there is requires additional complex step. Glucose oxidase can stand alone on the nanoparticle surface. So we need to introduce anilinkers, and we introduce the glucose oxidase. So this is very complicated step if we use glucose oxidase. But if we use glucose oxidase, it is very selective because glucose oxidase is a part of glucose itself. So it's very reactive if glucose oxidase can bond each other with glucose molecule. So to answer your question, in our current stage, I agree to you. And the commercialized glucose that we use is also contain monosaccharide. So for further testing in the complex solution, we should consider about the replacement of functional groups.
Okay. Thank you, Natasha Salsabila, for the wonderful presentation. And so we will, before we continue, we will now take a short brief break to allow our judges to deliberate their scores. Thank you for your patience. We will resume shortly. Welcome back, everyone. We will now proceed with our next contestant, Sheikh Ahmad Safwan bin Sheikh Sabri, with the presentation entitled Influence on Composition Ratio and Calcine Temperature on the Properties of SCSZ-SDC Electrolyte Composite for Intermediate Temperature Solid Oxide Fuel Cells, SOFC.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Syed Ahmad Safwan bin Sheikh Sabri. My metric number DD200190. My supervisor is Associate Professor Technologist Dr. Hamimah binti Abdul Rahman. I am from Faculty of Mechanical and Manufacturing Engineering at UTHM. So I am presenting my research, which is the influence of composition ratio and calcine temperature on the properties of SCSZ-SDC electrolyte composite for intermediate temperature solid oxide fuel cell SOFC. Next, in background of study, if you can see on the SCSZ SDC have high potential in efficiency and durability benefits. SCSZ SDC also show the remarkable activity and stability in oxygen reduction reaction. So this need to further research to fine-tune SCSZ SDC for commercial viability. The significance of this research in advancing SOFC technology for enhanced performance and efficient in energy conservation. For problem statement, we need to explore mix variation, test different SCSZ and SDC ratio for improved result, to find the perfect mix to identify the right SCSZ and SDC ratio for the very good performance. Then identify and characterization the chemical compatibility, porosity, morphology of the SCSZ composite electrolyte, and then to evaluating the ionic conductivity and electrochemical performance of the SCSZ composite at varying temperature, which is 600, 700 and 800 degrees Celsius. So here I have two objectives for this research, which is the first one to evaluate the characteristic of the pressed SCSZ electrolyte composite. Second, to elucidate the electrochemical characteristic of the electrolyte composite at the temperature ranging between 600, 700 and 800 degrees Celsius. Next is the scope of study. The first one is the composite powder development by combining two materials, which is SCSZ and SDC, by using high energy powder milling. Second one is the chemical compatibility, to check the compatibility between SCSZ and SDC through SRD phase identification. The third one is the pressing for creating the electrolyte pellet by using unaxial pressing. Fourth, the characterization using the porosity using Archimedes principle, and morphology using the scanning electron microscope SEM for obtaining the electrolyte composite. Then lastly is the electrochemical performance testing at the 600, 700 and 800 degrees Celsius under ambient air condition. Okay. As we can see here, the electrolyte composite requirement in SOFC. The first one is the minimal electronic conductivity. Why? Because to prevent losses of the electron. Second is the high ionic conductivity. This one to allow the transportation of the ion between cathode and anode. The third one is the gas tightness, because the electrolyte must be like a barrier between the fuel and oxidant gases to prevent the direct mixing. And then lastly is the chemical and thermal stability, should maintain functioning under the high operating temperature. Okay, as we can see here, the electron flow in SOFC. From the right side is the cathode, oxygen from air enter, and then from the anode, hydrogen enter and water going outside. Electrolyte is allow oxygen ion to move from the cathode to anode but block the electron. The electron is going from anode to cathode. Okay, as we can see here is the flowchart of creating the electrolyte composite. The first photo shows the SDC and the second photo shows the SAZ combining in high energy ball milling in 100 rotation per minute for 24 hours. In ball milling using the zirconia ball and ethanol for combining these two powder, and then drying for 12 hours at 100 degrees Celsius, and then calcine this powder at 900 degrees Celsius for 90 minutes. The heating rate is 0.5 degrees Celsius per minute. And then we go to the characterization SEM for check the proper mixing every ratio and agglomerization of the two powder. And then SEM also can do the EDI mapping to see the separation of the element and then the distribution percentage of every element in SCSSDC. Next is the SRD to identifying the chemical compatibility and the element inside, and also can find the crystal size of the SCSSDC. Next, go to the pressing of 0.5 gram in at 1 ton. The holding time is 2 minutes. Okay, after pressing, we go to the sintering process, which is to strengthen the pellet. Before this, the pellet will be fragile if we not do the sintering process. Sintering process at the 900 degrees Celsius, the soaking time is 90 minutes. And then we go to the porosity test by using Archimedes principle. We soaking the pellet in the ethanol for 24 hours. And then lastly, the electrochemical testing at the temperature 600, 700 and 800 degrees Celsius. The frequency used is the 1 Hz, and then the AC voltage amplitude is 10 millivolt. Okay, next we go to the result and discussion. On the result and discussion, we discuss about crystalline size, porosity test, ASR value, and the ionic conductivity value. Okay, the first one is the crystalline size. The crystalline size shows the result of the 5 ratio, which is 50-50, 60-40, 70-30, 80-20, and 90-10. The closer mesh in the crystalline size is very good, which is 80-20. Very close to the value SAZ and SDC, because the overbalance and between ionic conductivity and mechanical stability. Even the smaller crystalline size highlight the effectiveness, but the 80-20 is the close result is very good. Okay, next is the porosity test. The results show the percentage in between 20 to 40. 20 to 40 is the requirement of the cathode porosity. The reason why take the cathode requirement, because the electrolyte will be combined to the cathode for the transportation of ion. The very good porosity is the 80-20, which is the highest one, 36.64%. Okay, next is electrochemical impedance spectroscopy, which is EIS. The first photo shows the setup before put it in the furnace for burning at 600, 700 and 800 degrees Celsius. The second photo is the circuit that can got the resistance and CPE value. This is the result for Nyquist plot of SCSZ composite electrolyte at 600 degrees Celsius, 700 and 800. The trend is same, which is the 80-20 is very the lowest one, and then 50-50 is the highest value. From the EIS testing, can calculate area specific resistance. The lowest ASR value is the best performance, and then the result got the 80-20 at the 800 degrees Celsius is the best ASR value because of the lowest ASR all over the temperature. It can be effectively reduce the overall resistance in the fuel cell, thereby to improve its performance. From the EIS testing, also can calculate the resistance and ionic conductivity. The results show the 80-20 is the best all over the temperature. The result for 800 is 21.25, for 700 142.30, and lastly at 600 is 855.00. And then the conductivity at 800 is 59.95, and for 700 is 8.95, and then lastly for 600 is 1.49. The best resistance is the lowest value and the high conductivity. For the 80-20 is the very suitable mixing with the composite cathode, because it will be effective support and electrochemical reaction in SOFC. In conclusion, the study successfully developed SASDC electrolyte composite using high energy ball milling and calcine temperature at 900 degrees Celsius. The 80-20 weight ratio of the SASDC showed the best performance with the high ionic conductivity and the lowest resistance, making it ideal for intermediate temperature SOFC application. The composite had excellent chemical compatibility, appropriate porosity, and effective material distribution. The data collected from the porosity test, the EIS measurement show a clear relationship between porosity and electrochemical performance across the different composition temperature. The EIS data indicate the composition with the highest porosity, such as the 70-30, 80-20, generally exhibit the lower resistance and the high conductivity, leading to the lower ASR value. This finding highlight the critical role of the material microstructure in electrochemical performance, where the highest porosity facilitate the ionic transport by providing more pathway, thus reducing the resistance, enhancing the conductivity. Effective operation required a low resistance and high conductivity. There are several recommendations for this ratio, which is after this we need to focus more on 80-20 ratio because of the competition due the superior performance. And then next is the real world testing validate the performance under particle operation condition in actual SOFC system, and advance the characterization using the advanced technique to gain deeper insight into the properties. Next, the hybrid system by explore the integrating of the composite with the other material for enhanced performance. The further testing will conduct more tests, refine properties to find the stability and determine the optimal operation. Okay, that's all from me. Thank you.
Okay, thank you, Sheikh Ahmad Safwan, for your presentation. Okay, based on your slides, you claim that you carried out calcination at 900 degrees Celsius, and also there are also claim that sintering was also done at 900 degrees Celsius. So my question will be, what is the difference between calcination and sintering?
Okay, the difference between sintering and calcination, the sintering process is the below melting point, and then the calcination based on melting point of the material property. Aku salah. Aku salah letak asing. Okay, that dance.
Next question. Okay, Sheikh. I would like to ask about the porosity. So, for porosity, you are correcting the porosity by using Archimedes technique and SEM. Okay, so
Yes, brother.
why does you need to use these two methods?
Okay, the porosity is used for testing because electrolyte is to transport the ion. So we need to do the porosity test to know how porous the electrolyte to transport the ion. So the result that I got is the high porous, like 80-20 is the highest one, and the EIS result show the good transportation ion that low resistance and high conductivity.
Okay, perfect. This is the last question. The optimum calcination temperature is 800 or 900, right? From your experiment. My question is, the higher of calcination temperature will enhance the conductivity of the product. But why you are not using 1000 degrees Celsius of calcination temperature? Is it any limitation if you are using 1000 or any other reasons?
I choose 900 degrees Celsius because of the based on previous research that usually on the others material use 1000, and then for this material want to below the melting point. So uh, the calcination is based on the melting point of the material property. So I choose the 900 degrees Celsius because I guess is the perfect temperature.
Okay, thank you.
Thank you.
Okay, thank you, Sheikh Ahmad Safwan. So now we will take a short break again to give our judges time to deliberate the scores. Thank you. Okay, welcome back everyone. Moving forward to our next contestant, Gulin Nayab with the title Green Shield Easy to Decompose Plastic from Black Soldier Fly SUV.
Ranked second for annual plastic usage. Hello everyone, Assalamu alaikum. My name is Gulenaya and I am doing masters from University Tun Hussein in Malaysia under the supervision of Dr. Farida binti Kormin. Today I am here to present my presentation on the title Green Shield Easy to Decompose Plastic from Black Soldier Fly Exuvia. I would like to start my presentation with the name of Allah, the most beneficent and the most merciful. As you all know that we live in an era where plastic is a basic need for all people worldwide. People prefer traditional plastic because it's cheap and easily accessible as compared to the biodegradable plastic, but it comes with significant disadvantages. It harms both humans and ecosystem. The most commonly used petrochemicals for plastic packaging are polyethylene, polypropylene, and polyethylene terephthalate. In Asia, if we see Malaysia ranks second for annual plastic usage per person after the Philippines. So, in order to tackle this problem, biodegradable plastics has the potential to combat pollution by breaking down with microorganisms, thus reducing the environmental plastic buildup. So, in my research, I also prepared a biodegradable composite film by using the black soldier fly exuvii. As the Malaysian weather is humid and warm, and this weather is favorable for the production of black soldier fly. In Malaysia, the production of black soldier fly is very high. That's why there is a lot of waste of black soldier fly, which we call black soldier fly exuvii. So black soldier fly exuvii are basically the shed exoskeleton. As you can see in this video that during the developmental stage of black soldier fly, when they become adult, they shed their exoskeleton. So, as these larvae grow, they periodically shed their outer layer. So, we can use this exuvii because this exuvii is nutrient rich. It contains the higher amount of fats, proteins, and chitin. So, for the summary of my presentation, we prepared biodegradable plastic, and we use the machine like twin screw extruder, pelletizer, and hot and cold press machine. So, after getting the thin film from hot and cold press machine, we can do characterization. Like for mechanical testing, the tensile strength, Young's modulus, and elongation at break shown the decrease as the black soldier fly exuvii content increased in the traditional plastic, like the LDPE. So, I am successful in making a flexible, eco-friendly alternative to traditional plastic. Although the mechanical properties are little bit reduced with increasing the amount of natural filler, but the traditional plastic is non-biodegradable, but incorporating the black soldier fly exuvii in it, it becomes the biodegradable. The novelty and inventiveness of my research is that for the first time we utilize the waste material from insect farming, and I made a unique combination of LDP. I prepared a unique combination by blending the black soldier fly exuvii, which has a brittle nature, with low density polyethylene to bring the biodegradability in it. The next one is the problem statement. Nutrition technologies grapples with the significant waste disposal issue due to the abundant production of black soldier fly, resulting in around 1,44,000 100,000 metric tons of discarded pupal exuviae annually. So, the nutrition technologist does not want to do any chemical treatment because it's environmentally hazardous and resource intensive. They directly want to convert the black soldier fly exuviae into the biodegradable composite film. So the ultimate goal of this research is to reduce environmental impact and create value from the waste. Like we can prepare biodegradable plastic from the waste of black soldier fly, like the black soldier fly exuviae. If we talk about the methodology, first of all, we need to prepare the sample. We cannot directly mix the black soldier fly exuviae into the LDPE. First, we need to prepare the black soldier fly powder. Then we need to mix it with the LDPE. But still, we cannot directly mix the black soldier fly exuviae powder with LDPE. We need the plasticizer and compatibilizer in order to bring the compatibility between the black soldier fly exuviae and the LDPE. After preparing the sample, we need to pass that sample to twin screw extruder to get the extrudates homogeneous extrudates. So after getting the homogeneous extrudates, we need to pass that to pelletizer to get the pellets of equal size. Then those pellets were put into the mold and then placed in the hot and cold press machine to get the thin film for characterization. We cannot directly run our formulation to high-speed blowing machine to get the biodegradable plastic because for running the high-speed blowing machine, the minimum requirement of sample is 3 kg. So if you have a lot of formulation, it's not recommendable to directly use the high-speed blowing machine. First, we need to follow the methodology, like we need to pass through hot and cold press machine. After knowing the best formulation, so for commercialization, we can pass through high-speed blowing machine to get the biodegradable plastic. So if we talk about the research, first of all, tensile strength. Tensile strength is basically the mechanical property. Tensile strength, elongation at break, and Young's modulus, these are the mechanical properties. So for a good biodegradable composite film, these mechanical properties should have higher value. So if we talk about the tensile strength indicates that the material's ability to resist tension and is an important property for determining how strong and durable a material is under stress. For a good biodegradable composite film, it should have a high value. If you see the graph, this graph shows that as the black soldier fly exuviae content is increasing, there is a decline in tensile strength. This effect intensified as the filler content is increasing. So in other words, we can say that lack of strong adhesion between the components is the reason behind their decline in tensile strength. The first one is LDPE, which has high tensile strength of 7.9 megapascal. So as you can see, if you see the comparison between the 10% black soldier fly exuviae with and without glycerol, they show a significant result. Like one without glycerol has lesser tensile strength as compared to the one with glycerol. So it means for making the biodegradable plastic, the role of plasticizer is very important. The next one is Young's modulus. Young's modulus is also known as elastic modulus, and it measures a material's stiffness or rigidity. It should also have a higher value for a good biodegradable composite film. This graph also shows that as the black soldier fly exuviae content is increasing, the Young's modulus value is decreasing because of the weaker interfacial bonding between the components. If we talk about the elongation at break measures a material's ability to stretch or elongate before breaking. This graph also shows that as the BSFE content increase, elongation at break decrease. This decrease can be attributed to inadequate bonding between the filler and the polymer matrix. This inadequate bonding results in decreased materials flexibility and reduced ability to stretch before breaking. The next one is scanning electron microscope. Results. If we see the analysis of the micrographs which are obtained after SEM, this graph shows that as the BSFE content is increasing, the interfacial adhesion between the components is decreasing. If you see the sample 2 and 4, both have the same black soldier fly exuvia concentration like 10%. But one is the sample 2 is without glycerol while the sample 4 is with glycerol. So the sample 4 has more smooth surface as compared to 2. Sample 2. Sample 2 has rough surface because it lacks the plasticizer like the glycerol. In conclusion, I am successful in making a biodegradable composite film, and through characterization, I came to know that all the mechanical properties decreased with increasing natural filler content, and the same analysis also showed a decrease in adhesion between the components with increasing natural filler content. And this research is funded by the Ministry of Higher Education and through FRGS, and we also have a collaboration with industry, nutrition technologies, and I also wrote a review paper which got accepted in Springer Nature with the impact factor 4, and I also got gold medal for this research in RISE 2024. Thank you.
May I know how sure your product is biodegradable? And what is the characterization test for the biodegradable? I'm sorry, cannot hear from you. You have to unmute your mic.
Sorry, I forgot to unmute. Sorry. You are asking about the biodegradability test? Yes, for that, I have run my sample for 7 weeks, and after the 7 week result, I came to know that the 100% LDP and the one with 5% concentration of black soldier fly exudia haven't shown any biodegradability yet. But the other samples, like 10%, 15, 20, 20 and 25%, they have shown biodegradability. And with increasing the with increasing concentration of black soldier fly exuvia, is increase in biodegradability, and the highest one is around 7.9% weight loss.
Okay, so the next question is, how do you find your BSFE supply? Do you harvest?
Actually, we have a collaboration with the industry, nutrition technologies, so they provide us.
Okay, they provide. Thank you. All right. So it doesn't really affect any cost, is it?
Yes.
Is there any cost?
I am prepared, but I haven't sent my sample for commercialization. But I know the price of LDP and other, but we haven't prepared the sample for commercialization.
Okay, so another thing is, how's your finding contribute to the current knowledge in your field?
Like the product which I will make, it is not expensive as compared to the other biodegradable plastic, and it is biodegradable, so it will not pollute the environment.
So I would like to ask about the BSFE. How fine
Sure.
is your BSFE this up with the LDPE?
Can you?
How fine is your BSFE? The particle size of your BSFE before you mix
It's
up with
around
the LDPE?
250. It's around 250 to 300 micrometer for size. Like the C which I use for making, what I can say, like for sieving, I use the C of 250 to 300 micrometer for size.
Okay, the last question will be, if you look at the mechanical properties, okay, when we add other materials into the virgin polymers, we can clearly see that the data will be decreased. Okay, models Young's decrease, the tensile strength decrease, and so on. So, what is the purpose of decreasing or degrading the original materials properties, which is already at quite a high level? Because based on your data, it seems that some of the readings shows that almost 50% strength or properties has been reduced. So, what is the benefit of reducing all those things?
Actually, the black, because if we whenever we add some natural filler in LDPE, so they have different in like nature. So that's why all the properties reduce. But by incorporating black soldier triaxia in it, although the properties are reduced, but still we can use it because it's biodegradable and it is not hazardous to environment. But using LDPE is hazardous and it pollutes the environment and also cause the soil erosion and some other problems.
Okay, that's all. Thank you.
Welcome.
Okay, thank you Gulenayap for your insightful presentation. Now, let's continue with our next contestant, Muhammad Nur Izzuddin bin Rosman, with the presentation entitled Synthesis and Characterization of Cinnamon Soap.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin bin Rosman. Okay. For my study, I'm focused on the topic of synthesis and characterization of cinnamon soap. Okay. For the introduction, soap is an everyday and essential product that has been integral part of human hygiene and daily life for centuries. Soap is a substance that, when dissolved in water, possesses the ability to remove dirt from surface such as the human skin, textile, and other solid. Soap are formed through a chemical reaction between alkaline substance and fatty acid in fat or oil, leading to the production of salt of free fatty acids. Soap come in a various size, shape, and purpose, such as soap can come in a solid bar soap or liquid soap. An example of the soap is herbal soap, toilet soap, antibacterial soap, laundry soap, and others. As for the herbal soap, is mostly used for medical purpose, which is to cure which focus on the medicinal purpose. As an antibacterial soap, as the name, the purpose is for the antibacterial soap. For the problem statement, a byproduct of household cooking activities, especially during the preparation and frying of foods using vegetable oil. Some waste cooking oil disposed by poor bouncing or drainage system. Waste cooking oil effect on the environment, such as plant and animal when interact with the waste cooking oil. To reduce the pollution produced by the improper disposal method, one such increasing development is to reuse the waste cooking oil in the creation of soap. to develop soap using rice cooking oil with an extension of cinnamon as additive. Okay. Objective of this study: to synthesize multipurpose soap from new cooking oil and US cooking oil using cold process method, to investigate impact of cinnamon as an additive addition on the soap characteristic, to evaluate performance of stain removal activity using bar soap. What I am doing here: to formulate soap from cooking oil, I bought US cooking oil and new cooking oil as a comparison, alkaline solution and cinnamon by cold process technique. What is cold process technique? Later I will explain it. 10 synthesis soap based on new cooking oil and US cooking oil, which had different 3 grams of cinnamon powder with ratio of 1:1, 1:2, 1:3, 1:4, and a single soap without additive. The soap was evaluated by examining its color, hardness, pH value, and the effectiveness against stain. What is cold process technique? Cold process technique is the cold process technique for making soap involve combining fats or oil with a light solution, which is the alkali, and at relative low temperature. Which is the most simple is the technique that by combining the oil and alkali in a low temperature or without any external heat. Okay. The flowchart or the process of the synthesis the soap. Firstly, preparation of material and equipment such as new cooking oil, alkali, which the alkali used is the sodium hydroxide and the other equipment. For the comparison, the oil analysis has been focused on the color, sonification value, density, pH value, FTIR, and free fatty acids. Next, the step 3 is to the soap production, which is the three main raw material, which is oil, sodium hydroxide, water, and the additive is cinnamon. Next step is focus after the soap has been produced. Focus on the soap analysis, which is focused on the color, hardness, moisture content, swelling test, FTIR, and stain removal. After that, data collection and all the process have been done. Okay. As you can see, this is the final product of the cinnamon bar soap that have been synthesis for 12 weeks. And next, we focus on the result. Okay, for the oil analysis, as you can see, for the color, new cooking oil has the brighter color compared to the West cooking oil, which has a darker color. It's because the West cooking oil, the oil has been used for many times, which change the color into more darker. But for density, both new cooking oil have a similar density, which is 0.9, and have the same pH value, which is in the value of 5. But for the supplementation value, the new cooking oil have a 42.08 and US cooking oil has 28.05 milligram per gram. Okay, for the FTR for cooking oil, as you can see in the second part of the focus point, both new cooking oil and West cooking oil show a similar trend of graph, as the value being shown that both new cooking oil have a similar value, which is 2,922 centimeter, which show that both new cooking oil have a similar properties. Okay, for the next result, for the soap certification, as you can see from the week 1, the color is more darker, and as you can see in the week 4, the color become more brighter as a result that the soap completely have been cured for 4 weeks. Okay, for the color comparison, by using new cooking oil, we can see the soap without additive have a white color or more brighter color compared to the soap using 12 gram of additive for the sample NC12 have the more darker color. Same for the using waste cooking oil. Soap without additive have more brighter color, as you can see from the sample of WC00 compared to the sample WC12. The soap have more darker color. This show that as the cinnamon increase, the color of the soap become more darker. Next, comparison of pH value for different composition of additive. As we can see, weight of additive, every sample have the different weight of additive, which is for NC00. Then they don't have any additive, and for NC0 3 gram of additive, we show that 0.96%, NC06 1.39%, NC09 2.08%, and NC12 which use 2.7 additive, similar to the rice cooking oil, but as the result for all the sample, it showed the same value, which is which the value is 8. This shows that all the sample soap has a similar properties of the pH value. Okay, next, the properties of the bar soap. As you can see, for the moisture, all the soap have a similar moisture content rate is 11.11%. Show that all the soap has a similar properties. But for the hardness, the range of the hardness is around 6 to 7. And the highest value of hardness for nucleic oil is on sample NC06, which is 7.67, and the highest hardness for the waste cooking oil sample, which is WC06, which is 7.33. Next, for swelling test. For swelling test, the purpose of swelling test is to see how the soap react with the 3 sample solution, which is sugar, salt, and vinegar. For sugar, you can see the percent of swelling test for both soap using new cooking oil and rice cooking oil. As the highest percent of swelling in sugar solution is sample NC06, which have around 4.5% of swelling, and the lowest of swelling is sample WC06, which has around 2.2% of swelling. But different for salt. This show that sugar is less acidic, indicating the soap structure might be less affected by the sugar properties. But for the salt, all the samples show a similar trend, which the percent of swelling is around 1%. This shows that salt may create a more gentle environment for maintaining the composition of bar soap formula. But for vinegar, solution, we can see that for using new cooking oil, 4 or just 3 sample, which is the NC00, NC03, and NC06, has less reaction on the vinegar solution. But for other sample, the soap completely react with the vinegar solution. These formulations are more likely to break down when interact with the vinegar. Soap containing waste cooking oil are more prone to degrade in acid environment. For the FTR result using the new cooking oil, as you can see from the graph, all the new cooking oil soap show a similar trend of which all the soap show a similar properties, and compared to the soap using waste cooking oil, the results show that all the waste cooking oil soap show a similar trend of graph. This show that both new cooking oil can be used to make soap, which the soap have the results show that the soap have the similar properties. Okay, next, for the stain removal testing. For this testing, we are focused on the 3 household stain, which is soy sauce, chili sauce, and lipstick. For the soy sauce, we can see as the amount of cinnamon is increased, the salt ability to remove the sand also increased. As we can see from the WC and for the sample NC00 and WC00, it showed that 87% of the sand is removed as the additive increase. Which is for the sample NC12 and the WC12, the percent of stem removal is around 94%. We show that as cinnamon increase, the ability to remove also increase. For the chili sauce, the graph show a similar trend, which is as the cinnamon increase, the ability to remove also increase. As you can see from the graph, the sample for NC12 and WC12 is have the highest percent of stain removed, which around 86% to 88%. And for the lipstick, also show the similar trend. For the NC12 and WC12 has the highest stain removal percent. But for all the three stain, soy sauce and chili sauce, all the samples show that have completely removed more than 80% of the stain. But for the lipstick, just NC12 and WC12 sample only remove more than 80%. This may be caused from on lipstick there is a wax or oil content which create a solid adhesion to surface. As a conclusion, if this finding suggests that bar soap made from waste cooking oil are equally effective at stain removal as those made with new cooking oil. Cinnamon is a cost-effective and eco-friendly alternative to synthetic chemical used in commercial soap production. This approach promotes a more environmentally friendly soap production process by utilizing waste material. Okay, that's all from me. Thank you very much.
Okay, thank you very much, Muhammad Nur Izzuddin. Okay, so I will start the question. So my question, just now you show one of your result, the pH value. There were no differences in the pH value, right? All are 8, even though there are different compositions. Is there any reason behind it?
Okay, thank you for the question. For, so far, as the result show, the additive doesn't give any effect on the pH because the pH of the soap is basically around 8 to 10, mean that the soap is fully developed. So the additive doesn't give any effect, even they have a different percentage additive use.
Okay, another thing, I don't know whether what's the main application of your developed soap, but there usually we use soap to actually to handle the germs, right? So how about your soap in that particular part? You know, is there any test conducted whether it kill germs or reduce the germs whatsoever?
So far for this soap, I focus for multi-purpose which we use for household, and I focus on the household state which the three tests which I use for chili sauce, uh, lipstick. That just focus on the how the stain will move by the all the soap.
Okay, right. Thank you.
Okay, thank you Muhammad Nur Izzuddin for your presentation. Last but not least, I would like to welcome our last contestant for today, Tiu Heng Yo, with the title Analysis of Contamination Effects on Insulation Material of Petrochemical Reformer Clay.
Hello everyone, my name is Teo Heng Yao and you all can call me Yao. So I'm currently studying my master degree at UTHM, University Tun Nusrat Malaysia. So my presentation today is about the analysis of contamination effect on insulation material of petrochemical reformer clay. So my project is supervised by my lecturer who is Engineer Dr. Azura binti Ismail. My summary about my presentation today are about the introduction, methodology, result and conclusion. In the introduction consists of background study about the petrochemical plant furnace and insulator, problem statement and also the objective of study. Next is the methodology, consists of the experiment steps, details of experiment conducted, and the result consists of the comparison of density and porosity, and discussion about the result of XRD, EDX, and also ESCM, and to the conclusion. So the first part of my presentation today, we start with the introduction, which is the background study. The focus on the secondary reformer of the petrochemical plant. The reformer clay is crucial insulation material used in high temperature furnace. And the application of insulator inside the reformer is very important because it can be enhanced the efficiency, maintaining high temperature and reduce the heat loss. The internal insulator and hot face insulator are used in the petrochemical plant reformer. Several experiments need to observe because of some failure occurs within the both insulator. Both insulators are important for petrochemical plants when processing oil and gas to produce plastic, industrial chemicals, and also pesticide. So the insulator have to always be in best condition to make sure there is no problem when producing product. So what is the problem statement of my topic of presentation today? There are few main points can be assumed. The first is the purpose. The purpose of this project is to investigate the contamination effect on insulation material of petrochemical reformer clay. And the focus is on the internal insulator and hot face insulator. Both insulators are the important role in the furnace for petrochemical plants. And the methodology conducted involve micrograph examination, physical properties, thermal properties, and chemical properties. And the impact of contaminant is to investigate how contaminant affect the insulation performance in petrochemical reformer clay. And what is the expected outcome is insight into optimal insulation solution for furnace and the petrochemical process, and then combination for improving the energy efficiency. So there are three objectives from my project, which is the first one is to identify the types and sources of contaminants affecting the internal and hot face insulation materials in petrochemical plants furnace. The second one is to understand the chemical and physical mechanism leading to the degradation of the insulation materials. And the last one is to evaluate the impact of contamination on the thermal efficiency and structural integrity of the insulation material. As we can see from the slide, it consists of two insulators, which is the first one, hot phase insulator, and the second one is the internal insulator. The hot phase insulator position is exposed direct to high temperature inside the furnace. Its function is to retain heat inside the system, prevent energy loss, and maintain efficiency. The maximum service temperature can be achieved around 1800 degrees Celsius. And the second one is the internal insulator. Its position is applied to the inner surface of the wall inside the furnace. Its function is to help to reduce heat loss, enhancing energy efficiency. And its maximum service temperature can be achieved around 1430 degrees Celsius. So why hot phase insulator and internal insulator selected inside the secondary reformer furnace? Because both insulator can maintaining high temperatures and reducing heat loss, withstanding harsh conditions, improving safety, and also enhancing the efficiency. Let's jump to the part of methodology. The first one is the density testing. Density testing is to measure the mass per unit volume of a material. The second one is porosity testing. Porosity testing is to measure the volume fraction of pores within a material. And next is the XRD, which is the X-ray diffraction testing. It can be determining the different phase present in the material and analyzing properties such as grain size, strain, and also crystal orientation. And then is the EDX, which is the energy dispersive X-ray. It often used in conjunction with SEM. It's designed for elemental analysis. It allows to visualize topographical detail at magnifications ranging from 10 to 500,000 times. And the last one is the SEM, scanning electron microscope, used to examine the surface structure and composition of materials at very high magnification. It can identify and quantifying the elemental composition of material using energy dispersive X-ray stereoscopy, which is the EDS, attached to the SEM. This is my experiment step about the topic of my presentation today. We start with the sample cutting. Using a diamond cutter, cut the insulator sample into 4 samples, which is with the size of 30 mm, multiple 30 mm, and 10 mm. And the insulator sample consists of 2 pieces of internal insulator and 2 pieces of hot phase insulator. And then we can do the density and porosity testing using an electronic weight scale. Weight those sample using a high precision balance and note the weight value to put in calculation formula. And then we do the XRD testing using an XRD machine and EVA software, scanning each sample with the XRD machine and then collect data to transfer to EVA software to find the peak element within the graph. So before we do the SEM and also the EDX testing, we need to do the sample coating first. Using the gold, which is the Aurum coating machine, the coating is to dissipate the heat buildup and minimize the beam damage with beam sensitive sample, and provide a higher secondary electron yield to improve signal to noise. Then you can do the SEM and EDX, processing the micrograph and fund the EDX to observe the micrograph using SEM and observe the element detected from the EDX. As you guys can see from the slide, is about the density versus the porosity graph. I have conducted this experiment using the standard of ASTM C373-88. So this graph is about the density value and also the porosity value, which calculated from the formula about the hot phase insulator and the internal insulator. As you can see, the left one, which is the hot phase insulator, the first sample, get the lowest value of the density but get the highest value of the porosity, while the internal insulator for the second sample, it get the highest value of the density but get the lowest value for the porosity. So what is the hypothesis? What we can get from the experiment is the highest the porosity, the lowest the density, and then the higher the density, the lower the water absorption. Next part is about the XRD result for the hot phase insulator and the internal insulator. We start with the first sample of the hot phase insulator. As you guys can see from the graph, I have conducted this graph using the EVA software, which I have found out the highest peak from the graph about the element, which is the carbonite, corundum, calcium aluminum oxide, and cristobalite. And then is the second sample for the hot phase insulator using the same step in the EVA software. So I found out the element which is the carbonate, corundum, calcium aluminum oxide, and also quartz. The comparison can be observed from this graph compared to the first sample. I found out the corundum and calcium aluminum oxide has the higher weight percentage compared to the first sample. And then is the first sample for the internal insulator. Also using the same step, I found out the element about the aluminum oxide, corundum, carbonate, calcium aluminum oxide, and also the silicon oxide. And the next is the second sample for the internal insulator. The highest peak found out about the element which is the aluminum oxide, corundum, calcium aluminum oxide, and also the silicon oxide. So for the second sample of the internal insulator, I found out the aluminum oxide and also the corundum weight percentage is higher than the first sample also. And we are now for the ADX result for the hot phase insulator, which we can see from the slide is the first sample. We did with the spot spectrum. For the surface of 250 magnification, found out the element which is the carbon oxide, aluminum oxide, and also the silica. So the highest weight percentage found out from the element is the oxide. Then for the second sample of the hot phase insulator, which we did with the spot spectrum, found out the element about the oxide, aluminum oxide, silica, and also the carbon. So the highest weight percentage taken by the oxide. Next is the first sample of the internal insulator. So give with the spot spectrum, found out the element which is the carbon, oxide, aluminum oxide, and also the silica, and find out the different weight percentage. So the oxide also takes place about the highest weight percentage. And the second sample of the internal insulator and found out the element which is the oxide, aluminum oxide, and also the silica. So as we can see, oxide always takes place for the highest weight percentage for the spectrum. This is the last part for the result, which is about the scanning electron microscope image. So the first part is the hot phase insulator, which is for the sample 1 and sample 2. Consists of different magnification, which is 250, 500, and also 1000 magnification. As we can see, for the left part is about the observation area and also the surface. And then we zoom into the 500 magnification to observe what is inside the observation area and surface. And then we zoom into the 1000 magnification to observe what is really inside about the observation area. So we found out the porosity. There are several porosity inside the surface. Next part is about the internal insulator, also did with different magnification, which is 250, 500, and also 1000 magnification. So the left part, as you can see, is the observation area and surface. So we zoom into 500 magnification to observe inside the observation surface and area. To find out porosity inside, and then we zoom into the 1000 magnification, we find out the porosity is fine porosity compared to the hot phase insulator. So we have arrived at the last part of my presentation today, which is the conclusion. The experiment conducted went well because all the testing come out with the observable result, and the result can do comparison between both hot phase insulator and the internal insulator. So from the experiment, I can improve the knowledge about the importance of petrochemical furnace and also the insulator. The last one is I can learn about the properties of petrochemical furnace and insulator. So what is my upcoming works about this experiment or my topic? So the first one is the thermal conductivity, the second one is cold crushing strength, and the third one is creep-in compression testing. So that's all from my presentation today. Thank you very much. If you guys have any question, don't hesitate to ask me. Thank you.
Okay, good. Okay, bye-bye.
Minta maaf.
Okay, good morning to you. A very simple question. What is the general material properties of insulator?
General material properties. As an insulator, actually, the insulator need to maintain high temperature when it used in the furnace. Also, can reduce the heat loss inside the furnace. Also, can enhancing the heat transfer inside the furnace.
I think.
Ya, Data.
Okay, since you already conduct a testing and there are 3 more left testing, so I would like to know what is your motivation in completing this research?
Actually, about the research is to find out the insulator. Actually, the insulator have the problem that it have been used around 25 years of service in the furnace. So, the furnace need to be observed within the experiment asked by the certain company. So, I need to do the experiment given from the company to find out the result they want. So actually the upcoming work there is consists of 3. Actually I got more experiment need to do. So what I have let it to be done first is the 3 I listed at the last slide for the presentation.
Okay, last question will be at 1,800 degrees Celsius. Okay,
Yes,
could you
better.
please name a few instances of possible inclusions that could exist?
You mean the contaminant inside the furnace?
Yeah, contaminants.
Actually, inside the petrochemical plant furnace, from the literature review, I found out inside the furnace actually consists of a lot of chemical substance inside, such as sulfur dioxide, nitrogen compound, also heavy metal inside. But I think if it already achieved around 1,800 degrees of Celsius, I think certain compound is already burnt within the temperature, I think.
Okay, thank you. That's all.
Thank you, Doctor.
Okay, thank you Tiu Heng Yo for a great presentation. With the last presentation, all contestants have successfully presented. We would like to acknowledge and thank our judges for their wisdom and honesty. Your dedication, expertise, and commitment have been instrumental in making this program a success. We deeply appreciate the time and effort you have invested in evaluating the participants throughout the whole competition. Thank you for your commitment. Now, we will be taking a short break to allow everyone to grab something to eat and give our judges some time to deliberate and finalize the scores. Please make sure to be back by 2:45 p.m. sharp, as we will resume our program promptly at that time. Whether you choose to rejoin us physically or virtually, it is important that everyone is ready to continue at 2:45 p.m. Thank you for your cooperation, and we look forward to seeing you all back at 2:45 p.m.